All right, coming up.
We actually discussed that we're doing our final project, which is you get to pick what you want. That's why I'm doing business owners. You can also have business owners.
Okay, this is our last week together. It's like bittersweet, right? We've all grown so much since we first started talking about the philosophy of Newtonian mechanics and where free will fits into your design and analysis. And so at this point, the goal is for you to build your own project. We've done this kind of 4 times already with every quiz that we built together. We kind of said like, all right, these are the things that I learned. This is what I'm trying to demonstrate my learning in. Let me create like what concept am I working on, and then what example sort of demonstrates that I learned that concept. That's sort of the main gist of what we're doing. In terms of like the format of this project, if you like those Jupyter notebooks and you want to try like doing something else, you can copy those notebooks over and like change them however you want. Like they're your note. Any change that you make is now your notebook. Like you own it forever. If you have a different idea, like the quizzes were all kind of handwritten and all the homeworks we did like handwritten stuff, then that makes sense too. Usually if you're doing some kind of analysis, it makes sense to either try to create like a table of like, this happens when that, same thing that we did for that last project of like, what happens when I change a variable? How does it affect my analysis? And then graphs are a great way of showing like, look at what happens over time or as mass is changing. And these are like big things, but graphs are great, tables are great. I offer this every year and no one's taken me up on it yet. If interpretive dance is like your method of delivery, I would love to see an interpretive dance sort of project about dynamics. But again, no one's taken me up. I'm just like, I feel like it would be really awesome. There's just not a lot of dancers that come through applied mechanics too, I guess.
Is there
So I'll start up. So I answered like really broad, really big picture stuff. Are there specific questions so far? Or even broad questions or logistic questions about the project? Not yet. Usually there's a lot of like individual questions about like, is this okay? Can I do this? I don't know. Yeah.
This is all we have left, just like this project and our final participation thing?
Yeah. So then later this week I'll put up that final participation grade as well. Yeah.
So you have to like come work on this during like our final block as well.
Oh, during the final block? So it is scheduled there. But we don't have a final. But if you have if you have like 2 or 3 finals in a day and this is one of them, I'm not gonna say anything. You can use it as like, hey, because you can get a note to say like, hey, I have 3 finals, can you reschedule 1? So I leave this one. I'm recording this, but don't tell, like, it's not meant to be like broadly known, but it's helped some people that are like finals there, but we don't have anything. Yeah.
So is it due? It says like the project's due Friday, or is it due at the time of our final?
So it's due Friday, but same with every other due date. If some people this week is totally booked, like everyone's projects and finals and papers are all this week, and then next week is free. Other people, it's the opposite, where next week is full of finals and this week is all review. So if that's the case, if you're totally booked this week, then finish it next week. Friday is final day. Sorry, this Friday is when it's due. Next Friday is final day for all submissions, because I gotta turn in grades on Monday. Yeah.
will be penalized for submitting late?
No, there's no penalties, just period for late submission. Yeah. and resubmissions for any homeworks and projects, no penalties. Yeah. Cool, thanks. Yeah. For final? No, I won't be here for the final. Yeah, the room is here if you, I don't know where it is. Sometimes it's here. I don't know, I didn't look into it, but the room is available, but we don't have a final. Yeah.
I don't think they want people bringing the slots because this is a land ahead.
So I handed out note cards, because usually I think that's a great way to start, of just like, what are the forces involved, what kind of motion are we thinking about, and just like, how do you take a complicated, or even just like a simple thing that you think you want to understand, turn it into like just the engineering things that are there. What forces, what MA, or even like what impulse, what momentum, like what's going on that way. So I'll check in on individual questions, and we'll see what's going on through the rest of the class. If you're watching online, and you do have more questions, Wednesday come in, and we can work together on anything. Otherwise, good luck.
Because you see, like you pull it and at the bottom something releases, so that the wheels have
What do you mean?
it's spinning around.
Go do piston cylinder assembly? Yes. Look, I have a picture and everything.
So on this
Piston cylinder
there's like the
assembly.
spring, but then there's also like
Not like we haven't drawn 40 of them last
Yeah.
time.
I guarantee the piston cylinder assembly.
it's less harsh than the spring.
It moves back and forth.
What is that called?
That one's called damper.
Damper.
It's one that
General
it'd be spinning it'd be spinning all over the place.
One name has fallen into a river system.
The man is fallen to the river. Is this the one?
That incorporates stuff like the Spider-Man problem. When he did the first one, he was swinging through buildings and just had to find this velocity.
Is this the one?
Generally.
I don't remember. Did you just pull up your Python notebook?
Yeah.
It might be the one that you made.
We
Edited it. Did you make a note of it?
No, I just checked like 2 minutes ago. No, I wouldn't hold your breath either. Probably by the end of this week.
Like Thursday.
I'm thinking like, you don't want them done by Thursday's class, but that's just speculation.
Yeah, that's what we hadn't done like before the review class.
Yeah.
Oh, yeah?
I don't know.
Maybe this one was kind of.
I guess
Are
we're
you thinking of like the
Good eye.
car?
Is there gonna be another review?
I was
something.
Legos, slot machine. The less if you can see how it's built, you can see how it works.
It's not wheels.
Well, not like that one though.
If it uses like Lego Mindstorm, back off the computer has systems.
Yeah, but those are the cool ones.
Yeah, this goes to
I still got my Lego ones.
Dude, same. They're so fun. I built one like a year ago.
That one. Before.
Maybe I just don't do the wrong thing.
What does that have?
It's not just.
So I have these similar constraints with dy equals 0 always because it can't move up and down because it has prismatic constraints.
So I know why it chooses what the earliest surface is as a function of speed, and I can start modeling. All right, what happens? Massive here is at x. Okay. Makes sense. Yeah. Okay. That one's a good like vibration, like solid.
So this is actually 1 degree of freedom, I think. This piston cylinder, I could be wrong.
Yes.
If this goes side to side, can't move up or down. This guy rotates,
I mean.
It's kind of similar to this one.
Okay.
Something we did.
Yes, yes. It rotates
It's very
based
similar
on,
to this.
rotates based on the position.
It rotates based.
Absolutely.
Absolute cinema.
Okay, let's see the Star Wars movie.
There's a Star Wars.
Oh, they re-released number 4.
Really?
With like 4K graphics, yeah.
There have been like.
No, my Instagram is mostly free.
Yeah, like.
Oh, but we never wrote strings for this. That's a bummer. So I'm trying to, like, my business cylinder assembly is actually quite similar to this. We never wrote, like, constraint equations, unfortunately. We just analyzed it as, like, a quasi-static system. But whereas for, like, this one, we had a system of equations. Keep it simple. Keep it simple.
So the balance was just stems back and forth, and it'd be pretty easy to make an equation to determine, I don't know, how to determine.
It doesn't have to be like 4 bar. It's like
Wait, why does a 4-bar linkage have two systems?
yeah, and you would
two
velocity
equations?
would be like take back and forth, back and forth, back and forth, like a sine function.
If you have one of the other angles, you use equations 1 and 2 to solve for the other two angles. But I only have 2 angles. I think I only need one equation for the figure out.
Yeah.
Remember you told me that the I don't know how because it springs and motor interaction, so I can't remember a little bit more complicated.
Maybe you don't. Maybe you do like
That's not what
exactly what it does. That's not what it does. That's exactly what it does. I said like out of 3.
It's like the same thing if you had like a wheel, it's right. No matter which way you rotate, it's going to try to come back to set.
Yes. Okay, what do I need to know? I need to set a couple things equal certain values.
But I think so you can't set it like no matter like where it's,
I mean, that's
it's
just
just the kinetic energy.
well, I was gonna like hold the whole question.
Literally everything.
That was fine. I'm just saying
We
this.
can show you the kinetic and potential energy. Everything ever.
Those are the
Yeah,
only.
so that's
ever exist in my
that
life.
one's kind of like,
Alright, that was a good one. Keep that on your own. You might come in.
Always draw free body diagram. I don't know. It's moving back and forth.
But it's.
I think it's gonna be on this, those are just supposed to say like how it's generated, it just want to like generate this much.
yeah, so for that one.
So dy is good because that's how all the piston cylinders work. It used to be good for nothing here, so then you lose some air.
Mass times itself.
So then,
So if you're saying it's a constant.
if we want to make sense, we just say.
The only thing that's overcoming is really like the.
That's why I'm like, okay. How do I get this right? So we have L1 sine theta 1, yes, plus L2 sine theta 2,
How
y.
our plane generates thrust.
So I think I could be wrong. If you have, it's a 2-bar lineage. If you have,
Then the next step is like.
so the sine of this thing and the sine of this thing should always be 0. Because that has to be dy is 0.
This much air.
You want this thing to be 0. And you're summing the vectors, the y components. So you go up this much and down this much, and that's 0. Okay, good to know. Equals 0 since that's d1. Okay. And then for the next component, L1 cosine theta 1 plus
Yeah.
this is where it gets confusing. It'll be equal to dx. There's a max. Because it slides back to, no, Q is how this is expressed. This is gone. Pretend that's a wheel. Dx will change as you push the language. If it goes back.
So I'm not doing your project.
No, I'm just saying. I'm just saying. I'm not doing your project. Thanks, man. The function input is a vector with two values, and the output is a vector with two values. So what needs to be known? The length will be known.
I was so bad like this morning. No, just for like you can kind of look at it as like when I got home.
Theta if you're going straight from 0 to 5 equals 0 to 360
And now with the banking, that's what FL equals FG plus the direct velocity. So now you needed to go from cruising with your T banking.
Wait, this might not be as bad as I thought. Hold on, we might be cooking something.
So in order to go
I explained what these were doing, they're just equal mechanical.
They clamp on the wire.
They clamp and then they close down and then they separate, but it's all in one squeeze.
With those monsters from Alien, where they open their mouth and open their mouth. To pull away the wire.
I grabbed it and it kind of, it's pretty good.
Did you just type all that out?
No, I'm.
Oh, you copied and pasted it? I was like, that's crazy. What? I just drew a picture. I don't know, I just worked here. I'm gonna initialize it. I just worked on it for like most of the night.
I have an idea. This one's pretty easy though.
Oh, there's nothing wrong with that. I feel like mine's easy. It's just cool.
Yeah.
Exactly. This thing is lovely and very
Yeah,
nice.
no.
What does it do?
That's a giant spring.
Does this rotate?
You put a whole piece of metal.
Oh,
And then you spin it really, really fast. No, it forces it into the cavity and fills up the cavity.
a plastic injection mold with extra steps.
But with molten metal.
So, an injection mold with extra steps.
Well, it's not extra steps. You can't do what you're doing with normal stuff with metal.
You can't use injection molds?
What are you looking for the
The average household person, no.
Okay. Average household person didn't have this.
I know.
Oh my gosh, I'm right. Also doing 4-bar linkage?
No, I'm trying to find the
Why
spider.
do you hate me? Because I'm right when I love 4-bar linkage. Chill. Motion like positional like that. Let's see what it looks like.
knee is kind of set up to be in one freedom. Yeah. But yeah, if it's under load, you can't. Every load will form.
O, A, B, yeah. We have like a fan.
It's just ACL, PCL, creates 4-bar linkage. But most of the time, rigid bodies would say fine. Yeah. Okay.
I was just, because I remember, that project one, like 50 units per year.
Yeah, exactly.
So I wanted to do like a garage.
I think I have to simplify this down.
Nice.
Because technically,
Go for a solid
is good for us.
instead of rolling.
Physics, I have to be fluids.
That one looks like it's like
Yes, it would.
great.
I
Unless you have rocks, it's just.
Because I probably would consider
Okay, do this for,
like to find a fairly good project, it'd probably be like
like,
4,700 as a standard.
so that's why
What?
I have like a facility in Georgia.
Can I
Stuff.
walk them like this? Can I get away with that?
But I was like,
Let's find it.
Yeah.
You could find angular momentum of the system.
Yeah, that would be great.
Get a load of this.
Do you have an idea
But
of
basically, it's just like spinning weights.
how the kinematics of it works?
There's no L3. Delete L3.
It looks like it's
Oh, you could do like a governor where you know, like the bigger is more in momentum as it spins faster, it's gonna have a larger number of inertia. Do your project about that.
to be honest, I'm not entirely sure.
What do you mean?
Okay.
Like a
Yeah.
Oh. Yeah,
And
but
you can
like,
take a look at like maybe there might be like two rollers
assuming it's a governor, it's
that
not
are
changing.
going along the
This.
track.
Well, it's not changing how far.
Oh, it changes everything.
Yeah, there's, the masses go farther out, the more it spins.
Not these.
Oh, not those, but I mean, you could.
Yeah, but like, you know.
Then again, I also might just see if I can do like a,
Maybe I'll
you
just
know, like
do it on a person.
little wire thing instead of, yeah, the one.
It might be something like this. This first roller is rolling this way and that one rolling like that way. And then when you close it, this one comes forward. and that one goes down. Which is
How do I move this? How do I move this cell?
roughly.
Also, like,
I'll delete this one off
how
here.
many cars did you get? How many cars did you get? You ready?
So that's a good start. Please,
When do you want to swing?
A linkage connecting to two sliding things. It's still like 1 degree of freedom. You just make the door as long down that way and as long as that way. It like goes open and close.
Can I just declare a variable like not assign an
Yeah.
value? Can I do that?
Yeah,
oh, no.
there was
Wow.
a question like,
Oh, name error?
Just give it like a zero.
No, because
the
it's,
same kind
so
of
the X changes, I don't know what
slide
the
down roll.
It started
It has
as
the
a
same constraints. Yeah.
Not if I said it.
So like the center here actually moves in a circle, a quarter circle. Or you have two kind of straight tracks. Yeah, that would be really cool.
I could agree with
If you want, you don't have to. If Jupyter was working and you want to keep trying new things in it, then you can do that. But you can make this project at any format that works for you. Yeah, some people do handwritten work, other people do
Alright, okay, go.
overboards.
You're done. So you need to finish your statement, I mean, you were lousy.
If I were to like reprint this or something, would that be something?
Yeah, yeah.
Maybe one of those marble, really coin funnel things.
Oh, I think I know what you're thinking about. You like let the coin go and it circles it until it gets to the bottom.
That's super not true.
Which is very not
You're
true.
just making shit up.
Yep.
I'm gonna open a Google Doc so I can copy and paste my code here.
Like how you each stage.
I think I was
Dude, when you saw one of these, you would have
yeah, one of those.
It was a good day.
I think it's gonna be interesting. I don't know how to,
When the plane is.
how to, like, make assumptions.
It'd be one of those things.
Friction is so
Okay.
Actually, no, you need friction if the coin's gonna spin.
I don't know if you're looking at it from a top-down view, but then how do you know how it's slowly rolling in? Okay.
No one's offering it.
If you had an equation for like total, then maybe you could.
Yeah, if you think of it as like, this thing has to travel on this path, right?
I'll put that one on the back card.
Another project.
I'm giving
This
myself.
sounds
an idea.
like a good project to do over the summer. You know what I mean?
Why would I do that?
I guess that could be something you could figure out.
You guys gonna be bored of this one?
But I don't do
Dynamics
dynamics
problems.
problems.
It's a brown well, but I don't know.
Oh, it's pouring the.
I know it's
Wait, why is F solved not defined?
We got the first, as I know the path, each one of these, like how fast it's going there.
Like a
Then every change is already.
This clearly is, I can see that. It's a giant model.
Went along with the path,
There's one of-
the radius was changing.
That was a lot smaller.
Alright.
$300.
Alright, so DX is not defined. I don't have it defined yet.
Radius.
No one can do that. Well, it's $4,000.
So 30 percent.
Yes, exactly, bro.
Oh, yeah, there's not.
DX is not defined. Where's DX?
Or what you could do is you could,
This radius.
like,
is
3D print
because I'm going.
the armatures and then like heat gun plastic. You could probably carve it up.
It's like a mold.
Yeah. That's like, well then you could make it tall. Dude, I got videos.
Like the kinetic diagram, right? And
And like molds like that.
We're gonna sell these giant coin things, we're gonna undercut the competition.
Oh yeah, for like $200.
this one.
No, we could undercut them by $1,000. It's $4,000.
So this
We could undercut by $2,000. There's no way us rolling a piece of plastic
Kind of
would
a-
cost us.
But that one, those are like, that one's just to really break them down.
Yeah.
Know
So you
a lot
did.
about what's happening, but how, so let me calculate.
We have the technology.
We don't have 3D printers on that
We
big.
do not have the funding, however.
That's also important.
Well, you
No, we go to the Yukon, whatever the idea is, that they have
Yes.
those things.
Yes.
That business.
What you do
DX
is
Is that
you
kind of
make
what
it
they're
count.
like asking about?
Like, you know how the guys will take like the sand and then they'll have like the thing and they'll just turn it around and make the symmetrical shape stuff. This guy doesn't watch YouTube.
Mm-hmm.
Bro does not watch, what's that guy, Mark Rober? He's a
Alright, now to think of an actual.
Yeah, like they're.
X is,
Actual.
what do you mean X is not defined? I just defined it.
When you use those intrinsic coordinates, now you're talking about what is the acceleration of the person in the plane. Because everything is relative to that. What you feel. And you move around that system.
Did you also, just like, the way I drew it on this, kind of like, we're just like here, it's kind of like, this way. Did you see it?
How to transition from going straight.
This is a problem.
Yeah.
Are you still working on the linkage?
Yes, they are working on my new video.
nothing, we just keep them straight, and then somehow we're gonna go like this. So let's say there's like some kind of. Do you want to capture everything, going straight, changing and going around?
The only reason I was doing this is because when I was looking at this part of it, which is determining up, is where 110 times the gravity happens, and then as it's going through the gravity, that's where the energy goes back to.
Okay. So if you know the
What? I know what that is.
That's not what I,
if you know the
how do you get this from this?
then you know
I don't know, that's just.
that A
Oh, I get flat.
is that ME squared, so then you know like what radius that thing is.
So we show more similar.
Oh, here we go.
So it's going from like constant radius to
It's a mechanism where.
Loki is
oh,
because it's field.
So it's a mechanism where as you open up this armature, I think loads a spring,
So it's just
which,
So
Loki.
yeah, but it's an arm into a spring.
I know,
into
which
a-
strikes Flint into this field.
Yes.
the normal acceleration. That's like that's zero.
But Loki is up on the arm.
So if you're in a plane, something, but anyway, you gotta find what is V. So let's say, assume that V is constant. So I wanna know if V is constant, how big of a radius is it gonna take to transition into the ground? Once I'm in there, that'll transition back out. Yeah.
Yeah, right here.
Yeah.
Oh, here, yeah.
Yeah.
Yes.
What are you doing?
I have my man who was falling into the river legacy.
The man is fall into the legacy. People don't just fall into the river. They get pushed into the river. Yes, it goes with us. Just saying.
Well, first he falls into the river, then afterwards the river pushes him to some velocity. Some velocity.
Do you
So
know
you need to
the
find
mechanics?
out. No, I'm making grab something.
We assume the water is actually just like a.
Or a rubber band.
Yeah.
Like a trampoline.
Or you should just do the boat.
Well, then afterwards we need to find the speed so the boat can go.
I texted this guy.
Yeah, like for there's a lot of air and helps a lot with turbulating. Try to get in maybe give it a lot of velocity.
The first project is a dam.
Takes all that fuel, turn it into lots of heat and energy. And then all that through. And then the way you get to the member, how much work does it need to do? Is answering questions like, well, how heavy is the plane? Split does it have? What is it going to do? How fast do we need it to accelerate? So now we get to like an hour.
What is my goal? I want to model.
That's a perpetual motion machine. That's a battery at the bottom.
I know. But like you gotta know how much.
Actually, you know,
That's actually
you
good,
don't need
that's
a
good.
battery if you're running out of radius.
Well, life is not ideal.
Okay, but programming.
Variables that would go into it. How heavy is the plane? How fast does it need to go?
Yeah, you can do it. You can see if like the friction force is this, how much energy it is in friction.
Or how long it'll go for until it stops.
Well,
It won't go.
yeah, from experience, it won't even make it over.
But when they turn it off, it just instantly doesn't work.
So you just find like what velocity it would take for it to work without a battery.
If I lean over this way.
Yes.
So, good, there were a couple of different devices I was trying to figure out which
Yeah.
one would be the most,
Yeah, like this.
I don't wanna say easy, but the most feasible with the program that we
Yeah.
have.
Okay.
And the first one was this Nanos wheel, I want to watch, because it's just,
Is that the timer? Like the thing that keeps track of like, seconds and hours?
so when the watch is going, it's basically the driving force of the gears to start moving. I'm trying to figure out where it's, I can show where it's going actually.
Like it's not oscillating, I guess.
It does oscillate.
It is oscillating, yeah.
Because it goes, it spins back and forth like this while the watch is going,
And it always stays
like this.
Yeah.
So it's a pretty simple thing where it's just switching from the spring is just pulling it back in either direction. And I'm just not exactly sure how I would try to model forces on this.
So that one, the spring that's in the middle, is called a torsion spring. And that one, the more you twist it, the bigger the torque it creates. And then see how the shape of the thing is like, has almost all the mass all on the edge, and then even extra like blocks of mass on there.
Yeah.
Those are probably like very specifically tuned so that the spring, that spring constant K over the moment of inertia I is the natural frequency of the watch counting. Because it switches back and forth. It's counting probably like, it probably does that every, I don't know. It looks like it's doing millisecond counting or like half second.
I do not know.
But that would be something that you would tune based on moment of inertia of your flywheel and the spring constant of your torsion spring. So it would look the same, like the equation looks exactly the same as like MA equals negative KX, but now it's I theta double dot equals negative K theta.
So theta double dot.
Yeah. So it has to have like, we have this thing, I'm drawing behind your head. A spring attached to a flywheel. So my free body diagram is the force created onto that flywheel is negative theta, full torque.
So everything is torque this time.
Yeah, because nothing's moving left or right, up or down. It's always twisting, none twisting up. And now I theta double dot is negative K theta.
Okay.
So instead of like a natural frequency of K over M, it's K over I. And it's describing like how quickly it bounces back and forth.
Okay. I'm just trying to figure out, because for the project we're modeling all this stuff, and we're doing graphs. And I know that the angular speed of it would just be like basically sine wave that was going, perfect system was going back and forth, back and forth.
Because it's the same idea as like a grandfather clock that uses a pendulum. It's just instead of a pendulum, you need something that doesn't depend on gravity, so you can wear it, and that that's what they did here.
Okay. Alright, and then, I don't know if I'll go with this one, I probably will, cause it's interesting to me,
Yeah.
but
Yeah, this
I
would be
was,
cool.
I was looking at other things, cause this is another thing that I actually have at home. It's it's called a centrifugal caster,
Okay,
so this is like a giant spring, and you wind the whole mechanism, and you have molten metal here, and a mold right behind it.
okay.
So you heat up the molten metal into a liquid, and then you release it, and it spits it into the gas.
Yeah.
To send the liquid into the mold.
Oh, okay, like create some pressure.
Yeah. So it's pretty dangerous. But yeah,
That's cool, yeah.
so but that's just basically the same thing. It's just, except it's not oscillating. It's just
That one's just uncoiling.
it just uncoils and then it reaches a point where it's just drags stuff down.
Yeah.
Yeah, and then this one I just looked at. I'm thinking I'm not really good at how to do it. You know, like all
Yeah,
the files.
yeah.
I have no clue how I would understand because the coin is moving and down a funnel and a weird cap, spiral cap,
Yeah.
like smaller. So that one is gonna.
Yeah, the coin, the mechanics of the coin rolling is really cool, but it is hard.
A little complex.
Yeah.
Alright, I'll start trying to
But
work on
it
this.
is fun.
Alright.
I have questions about, so I kind of cooked up this facility, so I labeled everything.
Nice.
dy is constant here, I'm assuming there's no elevation change between O and
Yeah.
point B. Yeah, so this is 1 degree of freedom because you have this rotation, you have prismatic constraints. I
Yeah.
was trying to set the valid system equation, so let me pull up the,
Yeah, perfect. That looks good.
so like in the same vein as this, L1 sine theta 1 I think equals 0 because dy is 0.
Yep.
And L1 cosine theta 1 plus L2 cosine theta 2 should be dx. This.
Yeah.
But dx is changing, so that's what I don't know how to account for in the code. So this is what I have so far. I just kept these arbitrary lengths.
Yeah.
I set dy to 0. I have dx in this equation. I think these equations are valid with the exception of I don't know how to account for the change because dx is changing. I can't like declare it beforehand as a constant because then it'll get
Yeah, so x is gonna be one of your
this one.
outputs. So you have two equations with two unknowns.
What are the unknowns?
Theta 2 and x, or dx, sorry.
Okay, I understand that. Theta 2 and dx are unknowns.
Yep.
But I should be able to solve for theta 1 with just the first equation.
Yep.
So then, I know the second equation can solve for dx
Yeah.
from the first equation.
Yeah.
So this should be fine, but my issue is like defining dx.
So now see where
I
see
commented
how you
it
use,
out.
like, x bracket 0, where
Here?
yeah,
Yeah.
in dx, replace dx with x bracket 1.
Bracket 1. And
So-
would you assume y would be?
When we set up that equation called f bar, we're setting up two equations with two unknowns,
Okay,
and the first unknown is angle 2.
right,
The second unknown is dx.
yes.
And now that we have like two equations that define like if they're 0, then we have the right theta 2 and the right dx.
But we have to
Okay,
Now,
now there's no error.
yeah, no errors.
I
right?
think, do you mind just like taking a look at this? I think this is right. I
It's
mean,
our
I
final.
was largely just referencing
It's
the
a
previous
final
one.
exam.
Yeah,
It's like a
exactly.
thing
Because I'm
where
not like
it's
super
three,
duper familiar with like the.
I mean,
So this is
that's
the
exactly
one.
the way it should start.
I guess what I'm saying is,
So now,
That's
the
it.
index is, so x is
Yeah,
0
which is
and x
the-
1, how are those different? Like
You might
x
wanna double check.
initial and x final?
But all I know is we have an exam.
oh no,
so
x is just
It's
like,
like the
it's a
component-
dummy variable. That's just describing theta 2 and x, and dx, sorry.
But dx is like the change of position, but x is like how far this is from the origin, how far the end of L2 is from the origin. And then you give good to
solder
know.
and jumper onto it.
This is cool.
And it was
But I think X is like how far the origin.
Cause I was taking
Yeah,
out
and
the
the
ice.
L2 are.
Yeah,
So I don't know if you need to define
It was
this,
stupid.
because that's what
It's
TX
very
is.
stupid.
that is DX, yeah.
Okay, so I just set TX set to X of 1.
Yeah.
Is that an array index?
Yeah, so in that function, F bar, for a given angle,
Mm-hmm.
there are two variables that we need. One is theta 2, which you have like sine of x0.
Yeah.
One is dx or x, however you want to describe, like however long it is to get to that distance.
So I would graph X bracket 1.
Well, the next one, look at the next, see how you're saying that A2 bracket I is x SOL 0? And then the next line.
A2I equals X SOL.
So that's where you're getting like, you're keeping track of all the angles of all the
So
data.
I'm putting them into an array.
Normally,
Yeah,
it's
exactly.
attached.
Okay.
So now you can get another line and say,
Another line within this cell.
yeah, you can enter and say like x bracket I
Equals X sol at like
bracket 1. Yep.
Okay.
And copy that line that says like A2 equals zeros and say x equals zeros.
Copy this.
Yeah.
And put it right below it.
Yeah.
Why would I do that?
It's called initializing the array.
Okay, so just like setting up.
Yeah.
So I can reference it.
Exactly.
So X equals empty. So X, you just make an array full of zeros.
Yeah.
That's the same length as A1. But then here you fill it.
Yeah. And then we're filling it up with all the answers that we found.
Oh, no problems. Okay, cool.
Yeah, no issues.
So then the next step is just
Yeah,
plot.
try plotting.
Yeah, kind of the same, except instead of like linear velocities.
Yeah.
Want to squeeze many questions here for today. I need to change stuff.
Put x into instead of 8.
So I think I probably have to give it an initial,
And what will the label be?
an initial name,
Your x. Yeah, we'll try x.
What do I replace data 3?
Yeah.
Yeah,
Yeah,
this is
that's
start.
Okay, just release X, right?
Yeah.
Do I need to
Yeah,
also
you could say that.
You can do.
I mean, we just
And
need
then
like an ideal.
X
so
label
it's
is
up and down.
R theta radian, and the Y is the.
That one's gonna be meters and radian, so just we'll take a look at.
Okay, let's just see what happens. Oh, nice. Okay.
Yeah, look at that.
So-
That's sine waves.
This is good.
That
So
is
this is
good.
showing how X changes. So at the beginning, X is the piston's extended, and then it's rotating back and forth.
Maybe sine waves. Depends on the units.
I didn't, yeah, that's it. So how do I read this?
That one is theta 2.
This is theta 2?
Yeah. When theta 1 is 0 and theta 2 is 0.
This is theta 1, I thought I got theta 2.
Oh, theta 2 is, see the blue.
Oh, the blue?
Yeah.
Oh, yeah, so this should be theta 2.
Yeah. No, oh yeah, that.
So I'm at x-axis.
That one, yeah, your x-axis is still theta 1.
Okay. So what else needs to be changed?
Pretty good. I have an idea of where to start.
Okay.
I was thinking about doing like, it's like I would do like short stuff, like push it.
Yeah.
I was like, there's anything I think about like, I was thinking like, I'm talking, follow that and stuff like that.
Yeah, okay.
Do you think that's a good start?
Yeah.
I look at the Facebook companies for like we use like an excavator, and I was thinking about I think the excavator is on 4 bar like there's like the arm, the 2 connectors are the
Yeah, so the bucket is definitely on.
Yeah, that's
bar.
yeah.
Yeah.
So I was thinking of modeling that and showing the dimension freedom and how it can like
Yeah, okay.
cool.
Yeah, I need some of it.
Is it like we're making like a question or?
Yeah, you can approach it like, one nice way to approach it is like similar to the quiz, like, alright, what question do I want to pose? So then you have to do some background research, like, how big is the area, like, where are the hinge points?
Okay.
So if I take a picture of it, how do I turn that into like a simpler diagram? And then usually it's nice to have like some
I'm sticking
kind
around, you guys can go.
of comparison.
Sure. Yeah, you got it.
Value. Like excavator full versus empty.
Yeah.
Okay.
Thank you.
Alright, thank you.
And so
Yeah.
Oh, also, me and a bunch of the other guys got.
Okay, good luck.
Is this better off as two graphs? That's what I'm struggling to understand. 'Cause this is how X is changing, but the thing says output equal in radians, which doesn't make any sense.
Yeah, so it might be better as two graphs since we're looking at distance and radius.
So just have one graph tracking theta 2 with respect to theta 1. And that should also be the same.
Should be, yeah, it won't be like control question. Now we're just looking at like theta 2 going up and down. And so depending on how this one again. I think you choose for the most part. I think
The rest were like, that's not like, what they couldn't do it with the other because it's all self-officiated.
oh, I just
So
if
she's
you put
like
it
really,
hashtag.
Oh, you
she
commented
had
that?
it
Yeah.
out of
So you
all.
commented
Just like,
the X.
it's
I
straight
just want to copy everything.
hard, so it's like, Like, we like tailed the dump. The way that we calculate, like, we like, nobody actually complains about like it. Like, you go up and you get like, if you like tap it down, there's no shoulder to take. You get like, I don't know if it's, I could totally get it. Yeah. That's fine. And then kept like,
This one, it's
we did rotate a single time. One of the times we played rotate,
you're measuring everything.
it's like,
Okay.
Movements, everything in your board.
that picture.
Yeah,
we got.
4.6 centimeters.
So this table one changes, this goes change, and that's the minimum,
Yep.
and that's the maximum.
Yeah, exactly.
So I should track the motion. I'll probably ask you what to do to track the motion and actually show it. It might not show well, if I just wait until down the line.
Yeah, just look at like,
Yeah, that's right.
everything.
Yeah, that was.
You got what's in the range.
The class.
Yeah, and X should be a straight line. This one should move around in a circle.
The other ones have like a kind of hard shape.
Yeah.
He said that.
I use similar stuff to take some, I don't try to like similar stuff.
Right.
Thank you so much.
Yeah, that's great.
And, yeah, we'll see if we can make it.
Okay. Yeah. Yeah. Maybe. But yes.
It's like, you like it about this.
Oh, okay. Yeah.
I forgot what it was.
Okay.
So I was just wondering, I was just thinking about it and because the ones that it's fine.
Oh, yeah, perfect. Yeah.
No, that's like my partner. And I was thinking about it. It's like a data.
Yep.
I was just wondering, did you give me
Want to try to build one?
I was thinking, design business, and then I worked somewhere. But like, part of the time is like just like, use that data to show
Good, how are you?
So those, are you trying to use those to measure temperature? Or?
If it makes me want to care about changing it. But she like wouldn't like get we've been trying to get on the we didn't like make one other this year or that we tried freshman year besides that. That was like, yeah, I'll play it like that should or should it just like, so I had to play that on the pulse of
To
we had
start, you
like,
you want to figure out like how big of a
yeah,
board you
like,
actually have.
cause I all went to home.
So,
It was like me.
so first question is sort of like, yeah, how much tension do you need as this thing is moving for coffee standing? And then the next question is, how fast do you want it to be? So then,
Full on like diving and staying out.
if you know how fast it's moving, and it can know, when the work's done, you know, whatever kinetic energy it has. Once you have those two things, now you know how much work you need, and you know how much work the composer needs to do. And then the last step is like, how fast do you want it to happen? So I think you know, my kinetic energy to go from 0 to, let's say, 10 joules in 1 second, and you get a 10 so like, and you needed it less than that. Now you know 100 so that would give a perfect, like, this kind of project would be a great way of choosing like what motor rate that would be a great output from this project. Thanks.
One round, like,
Yeah.
I'm gonna use like, this one, flashes. I want to take part of picture. I was like, after our whole team was like praying like belly scientists. I'm going all out, so I put my head down. Dude, I had so much fun with it for years about that. Yeah, I'm going to hang out with that too. Look at arms, I can't make it. I'm so shady. You can wash your own clothes. It was my Yoshi, and I was gonna put Yoshi in some towels.
Now it's a wash place. Oh, you're in this one. But yeah, like how is this should work? I was telling like everybody that you okay. He's right. You can do the same thing.
The way that you want to interpret it is
Right.
the only thing is I can make it saturated base.
Yeah,
like Jace, told them the other two, I'm not ever gonna get that.
So that
Like, I think one of them just came to you. Yeah, I guarantee you that was a job.
No.